Okay, welcome. Today we're going to be working, this is Foundations and Pre-Calculus, Math 10 with Mr. Johns. Today we're going to be working on section 4.2, which is irrational numbers. The first thing to know is what the difference between rational and irrational numbers are. Rational numbers can be written as a fraction. So rational numbers are numbers that can be written as a fraction, like m over n, where the denominator is not 0. So the bottom can't be 0. If written as a decimal, they will have decimals that terminate or repeat. This means the decimals will either stop or they'll continue in the same pattern. So if I have a number like 8, that's a rational number because it can be written as 8 over 1. If I have a number like 2/3, that's also a rational number because I've written it as a fraction. As a decimal, it's equal to decimal 66666 repeated. So the 6 will repeat, like we said in our definition. Another example would be like 3/8. And 3 over 8 would be like 0.375. So the number terminates or stops. If I think of the square root of 16, that's equal to 4, and it's also a rational number. Now, if we look at irrational numbers, they're basically the opposite of rational numbers. They are numbers. Irrational numbers are numbers whose decimals don't repeat or terminate. So if I take a number like the square root or the third root of -12 and I punch it into my calculator, I just get a crazy number like -2.28942, and it just continues, but it never repeats itself. So this is an irrational number. So let's look at example 1. We want to find the value of each root and then state whether each number is rational, and we can use an R for rational, or irrational, which we'll use an I, using a calculator. So to take the square root of 225, I'll simply use my calculator, and I get 15. Well, 15 is definitely a rational number, because I can think of it as 15 over 1. If I want to take the third root of 15, I'll use my calculator again, and I get 2.466212074, and as far as I can tell, this is not repeating. So I'm going to estimate it to 3 decimals and then say that it is definitely irrational. Now here I have a fraction under my square root. So if I take the square root of 4 over the square root of 25, those are perfect squares, I get 2 over 5. Punching 2 divided by 5 into my calculator, I get 0.4. Well, that definitely terminates. So that is a rational number. Let's try another example. We want to order the following on a number line from the least or the smallest number to the greatest or the biggest number. So if I think of the square root of 18, I'm going to use my calculator, find the square root, and it is 0.4 or 4.24, and I'm going to round up to 3. But it seems to just repeat itself. It seems like it's an irrational number. If I want to take the third root of negative 29, again I'll use my calculator. And I get negative 3.07, and I'll round to a 2, put a dot above my equals. And then the third root of 27. Well, I know that 27 is a perfect cube, so this is 3. So on my number line, I need to put these 3 values. Well, 4.24, that's like very close to 4 1/4. So I'll place it there, 4.243. Negative is less than 0, and it's just past 3. So this is negative 3.072. And then positive 3 will be right on positive 3 right there. And here's my 3 values on a number line. Now just to remind you, this would have been a rational number. This seemed to be an irrational number, and as did this seem to be irrational. Well, your task is to finish the assignment here. You want to find the value of each of these and state whether they're irrational or rational. And feel free to use a calculator. Then place these 4 roots onto the number line below. If you need any help, just ask. Good luck.